Hello viewers, in today's class we are going to solve some problems on three-dimensional geometry in which we are going to take up the topic that is equation of the plane passing through three non-collinear points, right? So here we want to find the equation that is the vector equation and the Cartesian equation of the plane which passes through these 3 points, that is A, B and C. Now here we are interested in finding out the uh, vector and Cartesian equation of a plane which passes through 3 non-collinear points, right? So here we are given 3 points, but here we'll first prove that these 3 points are non-collinear, right? So before solving this problem, let us have a quick look on the concept of the equation of the plane passing through 3 non-collinear points. So let us take 3 points, say this is A, this is B and say this is C, right? Now A, B, C are 3 non-collinear points, and let the coordinates of point A be x1, y1, z1, right? Similarly, the coordinates of the point B are x2, y2, z2, and the coordinates of the point C are x3, y3, z3, right? Okay, now we want to find the equation of this plane, right? Now let us take a general point, say P, on this plane, right? Okay, now let us now write the position vectors of these 4 points. Now let us take the coordinate axis as OX, OY and OZ, right? Now here if we join OP, then we have the vector OP as vector R, right? Okay, now we join OA. Now OA is vector A. Similarly, we join OB, and OB is vector B, and we join this vector C, right? So OC is vector C. Now let us join AB and AC, right? So we have joined AB and AC, and we see that if we find the cross product of vector AB and vector AC, then we see that the cross product of vector AB and vector AC is perpendicular to this plane, right? So the cross product of vector AB and vector AC is perpendicular to the plane. So it implies that this vector, that is vector AB cross vector AC, is parallel to the normal vector to the plane, right? So this vector is parallel to the normal vector. So the direction of, if we take the direction of AB cross AC like this, then the normal vector will be parallel to the this vector, right? So the dr's of this vector, that is AB cross AC, is proportional to the dr's of this vector n cap. So therefore we can draw the vector this AB cross AC, or the normal vector, like this, right? Like this, or AB cross AC, right? Now we see that this vector, that is vector AB cross vector AC, is perpendicular to, right? This is perpendicular to the vector AP, right? It is this vector is perpendicular to the vector AP. And what is AP? This vector AP is OP vector minus OA vector, and OP is vector R, and OA is vector A, right? So this vector AB cross AC is perpendicular to vector AP, which is vector R minus vector A. Now we know that if two vectors are perpendicular, then their dot product must be equal to 0, right? So here the dot product of this vector and this vector, that is vector AP dot AB cross AC, must be equal to 0, because if two vectors are perpendicular, then their dot product must be 0. Now AP is vector R minus vector A, and this is the dot, and then we have AB. Vector AB can be written as OB minus OA, and cross, here we have AC. AC is OC cross OA. Sorry, it is minus OA, right? Okay, so this expression can now be written as, we can write it as this is vector R minus vector A, and dot, and here we have OB is vector B, so it is B minus A, right? This is vector B minus vector A cross, and then vector C, this is OC vector is vector C minus vector A, equal to 0, right? So this is the vector equation of the plane passing through three non-collinear points, right? We can also further simplify it, and we can obtain a simplified form of this vector equation. Now let us simplify it. So here we have vector R minus vector A dot, so this is vector B minus vector A cross vector C minus vector A, so we can write it as vector B cross C minus A, and then we have minus A cross C minus A, right? And it is equal to 0. Now this is vector R minus vector A dot, this is B cross C, this is minus B cross A, and this is minus A cross C, and this is plus A cross A, right? Now see, A cross A is a 0 vector, and we can write it as vector R minus vector A dot, and here we have B cross C, and minus, this can be written as minus B cross A can be written as plus A cross B, and this minus A cross C can be written as plus C cross A, right? So the vector equation of the plane which passes through three non-collinear points can be simplified to this vector equation, right? Now here we have used the relation that the cross product of two similar vectors is always a zero vector, and A cross B is equal to minus of B cross A, because if we reverse the positions, then we get a negative sign here, right? Okay, now this is the vector equation, and now we can also further we can simplify it by taking the dot product of these two vectors, right? Okay, now if we simplify this vector equation into the Cartesian form, then we get the Cartesian form of the vector equation of the plane passing through three non-collinear points as the determinant x minus x1. Here we have y minus y1, z minus z1. Then we have x2 minus x1. Here we have y2 minus y1, z2 minus z1. Then we have x3 minus x1 and y3 minus y1 and z3 minus z1, and this determinant is equal to 0. So this is the vector equation, and this is the Cartesian equation, right? So this is how we get the vector and Cartesian equation of a plane passing through three non-collinear points, right? So let us now solve this problem, and we'll first find the Cartesian equation, and then we can convert the Cartesian equation of the plane into its vector form. Now before finding out the equation of the plane, let us first show that these 3 points are non-collinear. So for this we can make use of either distance formula or the concept of direction ratios. So this point is x1 y1 z1, this is x2 y2 z2, and this is x3 y3 z3, right? So let us first find the direction ratios of the vector AB, right? So we know that the direction ratios of a vector joining 2 points is the subtraction, is the difference of the corresponding coordinates. That is, the direction ratios of vector AB are x2 minus x1, y2 minus y1, z2 minus z1. So this is 3 minus 2, this is 4 minus 2, and this is 2 minus minus 1. So this is 1, this is 2, and this is 3, right? Okay, now find the direction ratios of the vector say AC. So the direction ratios of the vector AC will be x3 minus x1, y3 minus y1, and z3 minus z1. So x3 is 7, so we have 7 minus 2, then 0 minus 2, and then we have 6 minus minus 1. So this is 5, this is minus 2, and this is 7. Now we see that from the direction ratios of vector AB and direction ratios of vector AC are neither equal nor proportional, right? So we see that the direction ratios of vector AB and vector AC are neither that is equal or proportional, right? So therefore these two vectors are not parallel or collinear, right? So therefore these 3 points are non-collinear. So once we have shown that these 3 points are non-collinear points, it means the points are like this. This is A, this is B, this is C, and this forms a plane, and we have to find the equation of this plane, right? So these 3 points are non-collinear. So we know that the equation of a plane which passes through 3 non-collinear points is x minus x1, y minus y1, z minus z1, and this is x2 minus x1. Here we have y2 minus y1, then we have z2 minus z1, and here we have x3 minus x1, and y3 minus y1, and z3 minus z1. So this determinant should be equal to 0, right? So let us now substitute the values of these 3 points in this determinant. So after substituting the values here, we get this determinant. Now if we simplify it, then we have x minus 2, here y minus 2, then z plus 1, and 3 minus 2 is 1, 4 minus 2 is 2, and here we have 3, 2 plus 1, here 7 minus 2 is 5, then we have minus 2, and then we have 7, right? So this is equal to 0. Now this determinant is equal to 0, and we can expand this determinant along this row R1. So we have x minus 2 times we have 7 2s are 14 plus 6, then we have minus y minus 2, and then we have 7 minus 15, and then we have here z plus 1, and this is minus 2 and minus 10, right? Okay, so this is equal to 0. Okay, so this is x minus 2, this is 20, here we have y minus 2, here we have minus 8, and then we have z plus 1, this is minus 12, equal to 0, right? Now this is 20x minus 40, this is plus 8y minus 16, and this is minus 12z minus 12 is equal to 0. So this is 20x plus 8y minus 12z, and C, this is minus 56 and minus 12, that is minus 68, right? Okay, now we can divide the whole equation by 4. So we have 4 5s are here, and then we have 2y here, this is 3z, and this is 4 1s are 4, and this is 17 here, right? So viewers, this is the Cartesian equation of the plane passing through these 3 non-collinear points. Now if we want to convert it into vector equation, then we can write it like this: r dot, and here we have 5i cap, and then we have 2j cap minus 3k cap minus 17 is equal to 0. So this is the vector equation of the plane, right? And see, the direction ratios of the normal, to the plane are given by the direction ratios of normal to the plane are given by the coefficients of x, y, and z. So we have here 5, 2, and minus 3, right? So this is the Cartesian equation, and this is the vector equation. Now this equation can also be written as vector r dot 5i cap plus 2j cap minus 3k cap is equal to 17. And this equation is of the form vector r dot vector n is equal to d, right? So here the vector n is given by this vector and d is 17. Now the direction ratios of the normal vector are 5, 2 and minus 3, and if we divide this equation, right, this equation by this factor, that is 5 square plus 2 square plus minus 3 square, we get 25 plus 4 plus 9, and this is square root of 38, right? So if we divide both sides of this equation by root 38, then we'll get vector r dot here we have 1 over root 38, and then we have 5i cap plus 2j cap minus 3k cap is equal to 17 over square root of 38. Now see, this vector now represents a unit vector, right? This represents a unit vector, so we have r dot n cap is equal to say d prime, and d prime is equal to 17 divided by square root of 38, and it represents, this quantity represents the distance of this plane from origin, right? So in order to find out the distance of a plane from the origin, we must convert this type of equation into this type, right? Where here, see, this is the vector n, right? This is the vector n, but here this vector is a unit vector. So this quantity, whenever here we have a unit vector, then always this quantity will always represents the distance of the plane from origin, right?